Hello, guys. Good morning. Welcome to this lecture in of the reservoir and production engineering. Today, we will talk about the pressure drawdown. If you remember the component of a typical well, we have the reservoir, the casing or production line, and the wellhead. Okay, so today we will talk about the pressure drawdown. Before we get to the point, okay, I think you can see there are here some letters like PWF. PWF is the pressure at the well bore, okay. The PR is the reservoir pressure. The RW is the radius of the well, okay, the well bore radius, and the R sub R is the reservoir radius. Then we have the average pressure of the reservoir, and delta P sub DD is the pressure drawdown, which is actually our driving force in the case of a naturally flowing well. Okay, uh, here you can see I have tried to show the casing. Okay, this is the casing. Let me zoom it. This is the casing, and right close to the casing we have the, the well pressure. Okay, the well bore pressure. Yeah, and it goes without saying that the pressure at the well bore is always less than the pressure in the reservoir. Okay, you can see that there is a difference between the pressure at the well bore and the average pressure of the reservoir. Okay, because there is the natural or the initial pressure of the reservoir, and when you start producing, once you have introduced the casing and you start producing, due to the flow of the hydrocarbons or the oil, okay, from the reservoir to the production line, there is a drop in pressure at right at the uh, from I mean a gradual drop of the pressure from the reservoir to the to the well bore. Okay, there is a pressure drop. Okay, and this is our driving force in a naturally flowing well. So this green spot that you are seeing here macadamizes or represents the pressure at the well bore. Okay, and let me get I would like to emphasize on something is that you have to memorize or to know all these symbols that we are using right here, because we're gonna make use of them in the equations to follow, especially when we will be talking about the reservoir performance. In the reservoir performance we have the outflow, the inflow performance, and the outflow performance. The inflow performance is the performance of the reservoir. That means the the circulation of the oil from the reservoir to the wellbore, and the outflow performance is from the wellbore, from the bottom hole to the surface. Okay, so you have to know all these symbols by now, so that when times come that we will be using it, you shouldn't get confused. Keep in mind that the wellbore pressure is always lower than the average reservoir pressure, due to the reason why there is a pressure drop, and this pressure drop is our main driving force in the case of a naturally flowing well. Okay, let's talk about the reservoir outer drainage boundary. Okay, uh, the drainage boundary is the radius through which there is a drainage that the hydrocarbons or the fluid will flow towards the well. Okay, that means the radius in the reservoir that is affected by the flow, where you notice a pressure draw down. So our main focus as a reservoir or a production engineer is to calculate the flow rate of the fluid or of the oil from the reservoir to the production line. This is a picture of a I mean a spheric in the case of a spherical flow. Okay, you can see that the pressure, the reservoir pressure, is higher than the wellbore pressure, and the fluid is moving from the reservoir to the wellbore. And as I said, our aim here is to calculate or to evaluate the flow rate of the hydrocarbons from the reservoir to the production line. Okay. Next, in the next lecture, we will talk about the reservoir performances, and please get ready because it is gonna be a, I mean, a long lecture or a long chapter, and which is very important as a reservoir or a production engineer. And keep this image in your head. Always keep this image in your head, because we're gonna make use of it in all the calculations, the Darcy equations, and everything. Keep in mind that the wellbore pressure is always lower than the average reservoir pressure, and in a naturally flowing well, the driving force is the drop in pressure. Okay, so okay, thank you very much.